So now I'm going to run you quickly. We'll just quickly go over a couple of tensor operations. We did something similar with NumPy, and the logic is the same as we covered in the previous lecture. It's just that in this lecture, we'll just have a quick look at some of the mathematical operations that we can perform with tensors, and they're the same as what we do with arrays. So you can import NumPy as np, import torch. Now we are going to create a ones tensor by calling the function torch.ones, and as you can see, it has created a 4x4 tensor for me. I can resize it and flatten it so I have everything in one line by calling the function .format. Okay, this does the formatting. Tensor view 16.shape, tensor view 16, and as you can see, I get one straight line of tensor. So I no longer have it as a 4x4, and indeed I can even do it for an uneven matrix. So here I'll have to specify something like 12. So because 4 into 3 is 12, so there, and we run it, and this is what we get, torch size tensor. We can carry out basic addition with our tensors. I create a tensor T1 by saying torch.rand, and it creates a 2x3 row tensor and the 2x3 tensor here under the variable T2, and we can add these. So by saying torch.add, so I use the dot add function, T1, T2, I pass these, and if you add them, you get this tensor where 0.9385 and 0.2512, they have been added together. 0.87 of this and 0.43, they have been added together. So this is an element-wise addition. We can carry out subtraction. Again, I say T1 dot T2. So basically, this will give me T1 minus T2. And we can see the results. Sorry, T2 minus T1. No, it's T1 minus T2. So yes, T1 subtract T2, and these are the results we'll get. We can even do it the other way round by saying T2 subtract T1, which is going to give me T2 minus T1, and this is going to carry out element-wise subtraction the way we would do normally. Again, we can do element-wise multiplication by saying torch.mul T1 into T2, and we get element-wise multiplication. And that's how we end up with 3 rows and 3 columns and 2 rows. We can do element-wise division, torch.div T1, T2, which is T1 by T2. We can compute the mean, the average of one of our tensors. So I say T1.mean, which has given me the average. So it took all the values and gave me the average, which is 0.73. So these are some of the basic mathematical operations that we can implement on tensors. They're not very important because, and this lecture is just to give you a feel of this is how we would implement some basic mathematical operations on tensors the way we would with NumPy.